This illustration deals with grounding of service supply AC systems in accordance with 250.24D as in dog. Purpose of change: a new subdivision or section has been added. It has been added to clarify that the grounding electrode conductor shall be used to connect the equipment grounding conductors, the service equipment enclosure. Where the system is grounded, the grounded service conductor to the grounding electrode or electrodes are installed per Article 250, Part 2. The grounding electrode conductor shall be sized per 250.66. Section 250.24 has been reorganized and reconstructed for usability and for clarity. Next, I'd like to review the notes that kind of let the user of the NEC know just what is in this new subsection. Now, note 1 in the blue, right at the very top of the illustration, it states grounding electrode conductor is sized per 250.66 A through C or table 250.66. Now, basically what this revision is all about in this new subsection is that table 250.66 is used to size the grounding electrode conductor if you connect it to structural steel or a metal water pipe. 250.66A covers the size of the grounding electrode conductor to a driven rod. 250.66B talks about a concrete encased electrode and sizes the grounding electrode conductor. And then if you're dealing with a ground ring that encircles the building, you deal with 250.66C. Note 2 addresses a high impedance grounded system, which does provide a margin of safety for a maintenance electrician or electrician gaining access into the equipment to put it in a safe electrical work condition. And of course, you know that high impedance ground is talked about in 250.24D, but the rules for designing and installing it is in 250.36. Now, next I would like to call your attention to the grounding electrode conductor that's installed below the service equipment. Now, notice the arrow pointing to that grounding electrode conductor states grounding electrode conductor connects its neutrals and equipment grounds to earth ground per 250.24D. And I'd like to note it also grounds the grounding conductor coming in with the service conductors from the transformer located outside. The second thing I'd like to kind of cover with you is to the right, and notice we have a high impedance grounded system. And if it's 1,000 volts or less, we reference 250.66 for installation requirements. If you're over 1,000 volts you're dealing with, then we would reference 250.187 for the design installation of a high impedance grounded system. And then, of course, I would like to remind you that the grounded conductor, and you notice you have your raceway from the panel board, and that raceway encloses your ungrounded phase conductors, neutral and equipment ground. Well, I would like to remind you the sizing of it. You size it first from table 250.102 C1 if it's at the service, but if it's the equipment ground with an overcurrent device ahead of it, you would size the equipment grounding conductor by table 250.122. If you have neutral load involved, you go to 220.61 and you size a neutral based upon the maximum unbalanced load and take the larger of the two calculations. Be sure we remember that, or we may have an equipment ground that would be too small. We might even have a neutral conductor that would be too small if we don't compare the two selections of it and use the larger of which either one of these calculations provide the largest conductor.